Hey chemistry students, this is Mrs. Miller, and today we're going to be talking about how to identify acids and bases from their chemical formula. And this is where we're going to use the 4 magic questions. So you guys should have a red reference sheet that on one side has some information about pH and pOH, and on the other side should have these 4 magic questions that you guys are going to be asking yourselves to be able to classify something as an acid, a base, some sort of anhydrous, and a salt. Today what we're going to talk about is how we're going to classify different substances. And in our last video we talked about the Arrhenius acids and the Arrhenius bases, but there's a better theory out there actually, and it's called the Bronsted-Lowry theory. Previous to the Bronsted-Lowry theory, what we had is a definition for an acid that said acids are any compound that contain hydrogen and ionize in aqueous solutions to form hydronium ions or H3O plus ions. Well, there's a problem with that because there are some things that are acidic that don't necessarily have that hydrogen in them, but they do form hydrogen or hydronium ions when they're in solution. For example, carbon dioxide. Carbon dioxide is actually going to be acidic when you dissolve it in water, but the problem here is, according to that definition of what an acid is, it doesn't have a hydrogen, so how the heck could this be carbon dioxide being an acid? Well, we're going to use the Bronsted-Lowry theory instead, but first let's take a look at bases. According to the Bronsted-Lowry theory, there's a better definition for a base than what we already know. What we already know right now, or what we've been told at this point, is the definition of a base is any compound that contains hydroxide ion, OH minus, and ionizes in aqueous solutions to form hydroxide ions. Well, again, there's a problem because not every base has this hydroxide ion. Let's look at ammonia, for example. Remember, ammonia is one of those bases that I want you to know on site that is a weak base, and there's no hydroxide in there, there's no OH in there. So how the heck could this ammonia be a base according to our old theories with Arrhenius? Well, this is where we are going to move into the Bronsted-Lowry, and we are going to look at a better theory for how we're going to classify acids and bases. The Bronsted-Lowry theory is first going to talk about acids. And what it's going to talk about is the fact that acids are proton donors. And if you remember, protons are positive. So if something is a proton donor, it needs to give away something that is positive. So it's donating or giving away a positive particle. So a good way of thinking about this is protons are H plus in this case, or hydrogen ions. So acids must be giving away an H plus. For example, here we have hydrochloric acid plus H2O, or water, yields H3O plus. So this one gained a hydrogen. This one lost a hydrogen, or it donated. So therefore that would be the acid in this case. So we have our acid, and then in this case, water is actually acting like a base. On the flip side of this, we have our Bronsted-Lowry definition of what a base is. A base is going to be a proton acceptor. So again, protons are going to be positive. So it's going to accept or take something that is positive. Again, we know that protons are H plus. Bases are then going to take or accept that H plus because that's a proton acceptor. So the example here is where we take ammonium, we're going to add in H2O or water and make NH4 plus OH. Okay, so in this case, the NH3 is going to turn into NH4 because it's grabbing on to another proton, and therefore it's going to be considered the base, and this time water is going to be considered the acid. Well, there's a lot more to life than just having an acid or a base. There are going to be many different particles that are going to exist, and we have to classify them according to a different system because there's more than just acids and bases. We have something called anhydrides. One of the things that we have is called an acidic anhydride. An acidic anhydride is obviously going to act kind of like an acid, but to be an anhydride, it means that it's going to be something attached to an oxygen that react with water to form acids. And in this case, when we have an acidic anhydride, this means we have a nonmetal. So here we have the little purple steps, which would be the metalloids. So the nonmetals are all in blue over here. So anything over here that's also attached to an oxygen is going to be what we call an acidic anhydride. So we're going to take a nonmetal plus oxygen is going to equal that acidic anhydride. Anhydride literally means without hydrogen. So our nonmetal plus oxygen, notice there's no hydrogen, is going to form this acidic anhydride. We know that nonmetals are going to occur on the right-hand side of the periodic table, and nonmetal oxides are the compound of one nonmetal with oxygen. So examples of this would be carbon dioxide. Carbon is a nonmetal attached to oxygen, acidic anhydride. Sulfur dioxide. Sulfur, again, is going to be a nonmetal attached to an oxygen, therefore it's an acidic anhydride. Sulfur trioxide, using the same things, also nonmetal attached to oxygen, acidic anhydride. And NO2, or nitrogen dioxide, we have our nonmetal attached to oxygen, acidic anhydride. So what these are going to do in solution is they are going to take that acidic anhydride plus water, and they're usually going to make some sort of acid in that solution. So just keep in mind, if it's an acidic anhydride, it's a nonmetal plus the oxygen together. Well, if we have an acidic anhydride, we better have a basic anhydride. So a basic anhydride is now going to be a metal oxide that reacts with water to form a base. So now we have a metal plus oxygen, and that's going to equal our basic anhydride. Metals are going to be on the left-hand side of the periodic table, so all these in like this light yellowy color here. Those are all going to be our metals. Notice that hydrogen does not fall into that group. So we have our metals attached to an oxygen, which is a nonmetal. And some examples here are calcium oxide, so calcium and oxygen. Sodium oxide, here we have sodium, oxygen. Potassium oxide, and magnesium oxide. When we bring those guys together, CaO plus H2O yields CaOH2. So we have a metal and an oxygen combining with water to make some sort of a base, and I can easily tell that that's going to be a base because it has the OH, or the hydroxide ion, in it. The last category of substances that we're going to have are going to be salts. So anything that doesn't fall into an acid, a base, an acidic anhydride, or a basic anhydride is going to be a salt. So salts are going to be ionic compounds made of a positive ion from a base and a negative ion from an acid. So salts are created in those neutralization reactions that we talked about in our last set of notes, where we have an acid plus a base yielding salt and water. So when we classify, salts are going to be classified last because sometimes students are going to see that something looks like it could be ionic when really it's an anhydride. So you have to be careful to put those things together. So salts, ionic compound made of a positive ion from a base and a negative ion from an acid, like NaCl, CaCl2, metal, nonmetal, metal, nonmetal, metal, nonmetal. Calcium sulfate, metal, nonmetal. Most ionic compounds are salts, except for oxides and hydroxides. So hydroxides would then be a base, oxides would then be the anhydrides. And these are created from the neutralization reaction, where we take an acid plus a base. It yields salt and water, like hydrochloric acid plus sodium hydroxide yields a salt in sodium chloride and water. So now that you know the classifications that are possible for substances, well, is there like a checklist? How do we figure out what substance is what? Because we could have an acid, a base, an acidic anhydride, a basic anhydride, or a salt. So this is where that little red sheet, the 4 magic questions, are going to come in handy because it's going to allow us to classify these things as an acid, base, anhydride, or a salt. So the 4 magic questions, you're always going to go in this order. Number 1, does the formula start with an H? If yes, it's an acid. Boom, you've classified it. Super simple. If no, go to question 2. At question 2, does the formula have an OH? Yes! Then you have a base? No. Go to question 3. Is it a nonmetal, anything on the right-hand side of the periodic table, oxide? 1 nonmetal and oxygen. If that's a yes, you have an acidic anhydride. If it's a no, go to question 4. Is it a metal oxide? 1 metal and oxygen. If that's a yes, basic anhydride. If no, you have a salt. So this is the order that you're always going to be able to classify. First thing, if it has an H, you have an acid. If you have an OH, it's a base. 1 nonmetal and oxygen is an acidic anhydride. A metal and an oxygen is a basic anhydride. Literally anything else is going to be a salt. So let's try. So our first substance that we have here is H2SO4. When we take a look, does the formula start with an H? Yeah, it does. So yes, acid. Question 1, yes, acid. That's as far as we have to go. We went ahead and classified that with one really simple step. Okay, that's as easy as that is. If we look at our next one, now we have Na3PO4. Does the formula start with H? No. So question 1 was a no. We go to the next question. Does the formula have an OH? No. Because we didn't answer yes to question 2, we go to question 3. Is it a nonmetal oxide? Nonmetal? Nope. Sodium's a metal, so no. Go to question 4. Is it a metal oxide? We have a metal, but that's not an oxide. That's a phosphate. So no, this is going to be a salt. So you go in that order. No H, no OH, definitely not a nonmetal. It's a metal, but it's not a metal oxide, therefore it's a salt. Here we have MgO. Does it have a formula that starts with H? Nope. Does the formula have an OH? Nope. Is it a nonmetal oxide? Magnesium's definitely not a nonmetal, so that's a no. Is it a metal oxide? Metal? Oxygen? Yes! So therefore it's a basic anhydride. P2O5. Does the formula start with H? Nope. Does the formula have an OH? Nope. Is it a nonmetal oxide? P, phosphorus. Yeah, that's a nonmetal. Connected to an oxygen? Heck yeah. So we have an acidic anhydride. So follow those 4 questions and you'll be able to classify all these. The last one I have here is MgOH2. Does it start with H? Nope. Does the formula have an OH? Yep. Therefore, it's a base. So that was an example of the acid, the base, an acidic anhydride, a basic anhydride, and a salt. Your job is then going to be to complete the activity called What Are These? And you guys are going to use these 4 magic questions to be able to classify them as either an acid, base, acidic anhydride, basic anhydride, or a salt. Let me know if you have any questions. Otherwise, have a great day.